Hi dear students, welcome back. We were talking about the antigen antibody reactions, mostly the precipitation type of reactions. And let's continue. We are going to talk about the electroimmunodiffusion, the precipitation which is happening within the gel. Electroimmunodiffusion can mainly happen by three types of techniques. The first one we are talking today is a counter immunoelectrophoresis. In this technique, the simultaneous electrophoresis of both the antigen and the antibody will happen in a gel in opposite direction. Now you can look at this picture. You take a glass slide and the antigen and the antibody both are being put like cut and put in two different wells, and both the antigen and the antibody will diffuse through the gel, and at the zone at the zone of equivalence they would form a precipitation line. Now if they just diffuse to it, it's just called immunodiffusion. Now, if you put an electric current between these two points of the particular gel, that is, if you connect the slide with the electric current, the diffusion of the antigen and the antibody would also be under the influence of an electric current. So then you call it as a electroimmunodiffusion. So do remember, when just antigen and antibody react diffuses, it is called immunodiffusion. But since here an electric current has also been applied, you call it as a electroimmunodiffusion technique, and this is a example of a counter immunoelectrophoresis where both the antigen and the antibody is moving under the influence of electric current to different directions. Now the second type of thing which we have is a rocket electrophoresis. It has mainly been used for the quantitative estimation of antigens. So antigens in increasing concentrations, they will be placed in wells, punched. Now these are the antigen wells, and the antigen concentrations will be put of antigens of different concentrations will be put on different wells. And what happens is the antiserum will be put in this agarose gel, and you will give a what? Of course, there would be um, this it is see, electroimmunodiffusion technique. This is also a electroimmunodiffusion technique. So under the influence of electric field, what would happen? The antigens which are being present over here will diffuse from the antigen wells, and it will go and bind with the antiserum within the uh, what within the agarose gel. So because different concentrations of antigens are being used over here, like you will get a rocket like appearance, a rocket pattern of immunoprecipitation has been formed, and that is the reason why we call it as a rocket electrophoresis. Here the diffusion is one dimensional and a single electroimmunodiffusion, because it is the antigen which has been diffusing from the well towards the uh, to the antibody, and this will aid to make a quantitative estimation of the antigens. Now you can just see this is one which has been depicted. It's an example of a rocket electrophoresis. So that is to check. Now if you want to check like how much amount of antigen is being present over in a sample, you can do a rocket electrophoresis. Now you can see that this is the case of electroimmunodiffusion, where diffusion is combined with electrophoresis. I already explained it to you. Uh, this has already been explained, so then let me just move. And in here, in electroimmunodiffusion, the diffusion is combined with electrophoresis, and electrophoresis separates the antigen molecules according to the difference in their electrical charges, and after that they will combine with the antibody troughs, and the precipitin lines is also being formed. This is Laurel's two-dimensional electrophoresis, where the antigen mixture is electrophoretically separated, and after that antibody is being present within the gel, and you can form precipitin curves which has been formed later on. And so let me just conclude with what all we saw. In the gel precipitation, you can see that is called the immunodiffusion, and in the gel, when you use it, you can use it as a Wooden procedure where a single diffusion in one dimension happens, or Clifford-Thorpe procedure when a double diffusion in one dimension happens, a radial diffusion where single diffusion in two dimensions happen, Auchterlonie procedure, where a double diffusion in 2 dimension happens, and immunoelectrophoresis, that was where antigen and antibody will just diffuse. And again we have the electro immunodiffusion process, where the electric field is also being used combined with the immunodiffusion principle, and you can have counter immunoelectrophoresis, rocket electrophoresis, as well as the Rorel's method of 2 dimensional electrophoresis can also be carried out. And all these types of precipitations which we see, it could either be viewed by light, okay, and you can see that it follows the principles of turbidometry as well as nephelometry. You can, in turbidometry, it is mainly you pass light through the cloudy solution, and the reduction in the light intensity is mainly being used to measure the amount of precipitation. And in nephelometry, the light is, you measure the light scattered at a particular angle after being passed through the solution. That is it's an indirect measure. That is, you check how much light is scattered by at a particular angle, and the amount of light scattered correlates to the concentration of the solution. So the precipitation reaction can be viewed by following either the principles of turbidometry or the nephelometry. So greater the concentration of turbid nature, it indicates that it is a what? The light intensity which pass through it will be very less. So we can say that what is the concentration, you can have an indication. In nephelometry, you just look the amount of light which gets scattered by passing through the solution. That is the principle of nephelometry. And the usage of turbidometry and nephelometry has been used for the measurement of serum proteins concentrations, and they are being found to be rapid techniques. Fully automated techniques are there, and you can also use that for a large quantity of samples. So with this, we come to an end of the antigen antibody reactions, specifically the precipitation reactions which we were talking. Of course, do see the part 2 video also, because the part 3 video of antigen antibody reactions is a continuation of the part 2 and of antigen antibody reactions. In the next session, we would be continuing with the agglutination type of reactions. Thank you for now.